Welcome back, everyone. We are in the process of rebuilding this LC9 5.3 V8 out of my 2012 Chevy Silverado. In the last video we worked on the engine block, and today we're going to be doing some work with the rotating assembly. We're going to be sticking with the stock crankshaft and connecting rods out of this engine, but we're going to be going with a set of ARP connecting rod bolts, which you can get on our website www.jamzyonline.com if you want to support the channel and our family-owned small business. On engine teardown, the rod bearings were in near perfect condition, but as always we want to check the size with our new rod bolts installed. The rod's all checked out within reason, although leaning toward the looser side of tolerance. Be sure to subscribe and stay tuned for the build video where we discuss our clearances in depth, but for now we're moving on to fitting our pin bushings. We have a set of Icon 5/1000 oversized forged pistons going into this build with full floating wrist pins, and out the gate our pin bushings are about 2/1000 too tight, which obviously is not ideal. To counter this, we'll be honing the pin bushings out for the proper clearance, so we start with setting up our bore gauge so that we can accurately measure our clearance. To set the gauge, we take 2 wrist pins from our piston set and install them into this tool, which essentially clamps down to the exact diameter of the pins. We could simply use a micrometer and measure the pins, but this tool gives a more accurate transfer of the exact pin diameter to the Sunnen AG300 precision bore gauge. As we're honing the connecting rods, we will constantly be double checking our diameter on this gauge to ensure we do not end up with too little or too much clearance. In order to be as efficient as possible, we're going to start by roughing out 2 bushings at a time to about 0 clearance. When we're all finished, each pin bushing should have about a 0.5 clearance to the wrist pin, plus or minus 1/10 of a thousandth, and that may sound difficult to hit, but any machinist with some dedication and patience should be able to hit that on the money with this machine every single time. On top of using the bore gauge to check our diameter, we're also using a wrist pin and checking the diameter by feel. At this point, the wrist pin will slide in, which means we have clearance, but it still feels a little bit tight. At this point, we're talking just a few tenths of material left to remove, which goes by pretty quick, even honing only one rod at a time. If you aren't careful, it can be easy to miss your mark here, so it's important to take it slow and continually check your size. We also like to let the rod cool down before checking our final size, as the hone can actually generate a fair amount of heat in the material, and when you're dealing in tenths of a thousandth of an inch, that temperature change really does throw off your measurements. Now, if you're curious, removing this much material really doesn't take very much time, and in fact, it probably takes more time to set up the machine and the bore gauge than it does to do the actual machining. Even so, it's an important step in the process that really shouldn't be rushed.
I'm going through here real quick and weighing all of my rods and my pistons and the bearing and so on, and building out my bob weight card over here.
For balancing the rotating assembly, it's important to get an accurate weight of every component in the assembly from the connecting rods and pistons all the way down to the wrist pin clips and rod bearings. In an ideal scenario, all of these components are exactly the same weight for each cylinder. On the connecting rods, we're going to measure the overall weight and then the big end weight of the connecting rods and report these values on a spreadsheet.
So since these are the powdered metal style rods, cracked caps and everything, you'll notice they don't have balance pads on the small end or the big end. So if you do a bunch of grinding on these, you're pretty much just weakening them. They're not meant to have anything ground on them because they should be pretty close to balanced already. Looking at what I measured here, I kind of took an average of the big end, the overall weight. Same thing on the pistons. I averaged them, and you can see on the pistons we're pretty close, 0.3 grams from average at the most. On the overall rod, we're maybe 2 or 2.5 either way, and on the big end of the rod, we're not even as much as 2 either way from average. So I'm going to use these average numbers to build our bob weight card, and that's going to be as well balanced as it needs to be for this application because, it's my own engine, and I'm not building a race car, just kind of having some fun with it. So I've got the piston weight in, the rings, the locks, and so on to calculate that I need a bob weight of 1779.8 grams.
With our bob weights calculated, we can build them out and get them set up on the crankshaft rod journals in order to simulate the mass of all of the different components while we're balancing the crankshaft.
Bob weights are on. See what happens.
When we first spin up the crankshaft, I like to keep my hand over the emergency stop button. If something did go wrong, it's probably going to be way too late by the time I hit the button, but at least it's a good thought. I also haven't mentioned it in a while, but I really can't wait until we get our new shop building finished up so that we can do some much needed reorganization in here and set up a more permanent balancing area. After the first low speed spin at 500 RPM, the machine came back indicating that we were about 10 grams out of balance on the right hand side and about 3 grams out of balance at the left. Before going ahead and doing any drilling to remove material, I spun it up once more at the higher speed of 750 RPM, just to make sure we were getting a repeatable measurement. A little bit of slow motion footage here gives you a glimpse of the true controlled chaos that really exists in a running engine. This is basically at an idling RPM, so imagine what this looks like at 6,000 plus RPM. Moving on here, I went ahead and marked our location to drill on the far right counterweight, and took note of the 350 thousandths depth the machine is telling me to drill with the size of drill bit I have programmed into the machine in order to remove that roughly 10 grams of material. In the future, I'd love to get a drill press set up right here on the machine, but again, with this being a somewhat temporary setup while we work on the other shop, I'm still stuck moving across this shop to the TCM25 to do any drilling. Luckily, the drilling is a quick and easy process once you have the hang of it, and we can get right back over to the balancer to spin it up again and take another measurement. Now, I'm not sure what people do in other shops, but personally, with my experience balancing, I remove the weight from the heavier side and leave the lighter side alone, because when you remove weight from the heavy side, it can change how much weight needs removed on the lighter side.
So the machine wanted, what it originally said was about 3 grams removed from basically right here where there is nothing to remove. So what I did is I readjusted the machine so that it would look at this counterweight, and now it's telling me 6 grams right here. So we're going to go drill 6 grams out right there.
I've had pretty decent luck with drilling to the depth that the balancing machine tells me to, so I simply watched the digital depth readout here on the TCM25 and drilled to the desired depth, removing precisely the right amount of material.
Okay, hopefully my last spin.
This machine really is a little bit sketchy, so I always try to stand to the side so I wouldn't be directly in line if one of those bob weights did decide to come off, and I always keep my hands clear because it really could mess you up if it caught you.
If I want to chase it, I can do 0.8 grams right here. And 0.3 grams right here. I'm going to call it there. So we're 0.3 grams on the left, 0.8 grams on the right. I'm happy within a gram. If this was like a super high performance, race type engine, then yeah, I might, chase it as far as I can. But for going back in my pickup, it's a daily driver, just trying to do it as nice as I can. I'm not going to spend any more time chasing it any further than this because I think we're well within the range of a reasonable tolerance. And I haven't driven my pickup in over a year, so I just want to get this thing done.